In example 1, we're going to sketch one cycle for each of the following sine functions. So we have 3 examples for sine, and we're looking at different ways that they have been transformed. Notice that we're going to label 5 points, and I'm going to bring back my basic sine function first. So I want you to see that we labeled 5 basic points on both our sine and our cosine graph. So those 5 basic points, you can see sine hits the x-axis 3 times, and then we have a maximum and a minimum value. So basically I'm going to be asking you to graph these same 5 points on transformed sine graphs, and so we're just wanting to make sure how the transformations affect the amplitude, the period, the phase shift, and the midline. And that's how we're going to label our axes, but then our same basic shape is going to remain the same. So when I look at example A, it says y equals 3 sine x. That 3 is the amplitude, so it's looking at that vertical stretch. So if sine has an amplitude of 1, then 3 times sine, all that's going to do is vertically stretch that amplitude. So since I have a y coordinate of 0 at these 3 points, 0, pi, and 2 pi, those are not affected by a vertical stretch. So we're just going to be basically stretching this 1 up to a factor of 3 and this -1 down to a factor of 3. So whenever you're looking at transformations of functions, I would like for you to go ahead and write out the amplitude, period, phase shift, and midline if it's affected before you graph. So the only thing that's affecting here, this is just the A, is the amplitude. So I want you to put A, or amplitude, is equal to 3. So then when we graph this, you're going to graph your x and y axes. Instead of going up to 1 and down to -1, we're going to be going up to 3 and down to -3 for our sine graph. Now, nothing else was affected, so our 5 main points are going to remain the same. So our 5 main points again for sine are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are my 5 points. So I'm still going to do that, and I'll show you how I graph these when I do this by freehand. So I like to start at the end. If I know that I'm starting at 0, then I like to start at the end and put my ending period, so that's 2 pi. And then I like to go halfway, so to make it as even as possible when I'm doing this freehand. So I go halfway and I draw a tick mark, and that's going to be half of 2 pi, which is pi. And then I go halfway again and go pi over 2. And so then the remaining 5th mark, so remember the first one is 0, so we're going to include that as one of our points. So then our remaining one is going to be between pi and 2 pi, which is 3 pi over 2. And so once you get your axes labeled, then you're just going to follow the same basic shape as sine. So sine, I always remember, starts at its midline. And so that's a good, important piece that I want you to go and say. So sine graph, it starts, so when we're looking at one cycle, the start of the cycle starts at the midline. Okay, so that's where sine is always going to start whenever we transform it. It's going to be starting on the midline. So the midline here, it didn't get shifted, it's at 0, so we're going to still be at 0. And then remember, sine, if it's positive, it's going to start going up, so this next point, it's going to hit its maximum. Then it's going to come back down, and then down again to its minimum, and then back to its midline. All right, and so that's the basic shape of sine. Okay, so again, it looks almost identical to our original sine graph. We just made our amplitude now be a factor of 3 instead of 1. So for our second function, we now have a negative in front of our function. So the negative, it does not affect the amplitude. It still has a factor of 1, so the amplitude is 1. However, the negative makes this graph reflect across, hopefully you remember, it reflects across the x-axis. So it makes all the positive y values negative and all the negative y values positive. So what we're going to be doing, if I were to flip this original sine graph, it would just be reflected. So it would just look like this in my dashed line, okay? So we're going to be reflecting across the x-axis, and then we have this 2, which is now inside the argument, inside the parentheses. So that is affecting the period. That's affecting the horizontal stretch or compression. So for my period, so I'm just going to use P for period. My period is going to be 2 pi, and then we're affecting that by a factor of 2. So it's 2 pi divided by that 2. And so then we get a new period of pi. So what we're going to be doing is we're going to be shrinking this sine graph. So it's going to be reflected, and then it's going to shrink by a factor of 2. So what this is going to end up kind of looking like, I'll kind of sketch this here, is going to look something like this. Okay, so let me kind of highlight that in orange. All right, I want you to see this, how it relates to the original sine graph before we actually just graph it on the blank paper, so you can see how this looks compared to the original sine graph. So you see how the original sine graph is in this solid black line, and so then we reflected sine across the x-axis, so it's now flipped, so it's, instead of going up, it's going to be going down. And then we compressed the period by a factor of 2, so now we're going to be looking at one cycle in a span of pi instead of a span of 2 pi. So then, like, if we kept going, it would just keep going like this forever and ever in both directions. Okay, so I just wanted you to see that visualization of how these transformations are affecting. Okay, so when we graph this just on our blank paper, this is how I want you to do it. So again, we have our x and y axis. Our starting point, we didn't shift it horizontally, we just had a horizontal compression, so our starting point is still going to be at 0. Our amplitude is still going to be at 1 and -1. It's just, instead of going up to 1 first, we're going to be going down to 1. And then when I graph my horizontal tick marks, our period goes to pi, not 2 pi. So I'm going to go, my very last tick mark, I'm going to go all the way to pi. And remember, I want 5 points. So my first point is here at 0, then pi, and then I go halfway. So half of pi is pi over 2. And then I go halfway again, and so half of pi over 2 is pi over 4. And then I want a halfway mark in between the pi over 2 and pi. So another way you could do this is if I know that one like little tick mark is a pi over 4 length. So this is 1 pi over 4, 2 pi over 4. So this would be 3 pi over 4, and then our ending point would be the 4 pi over 4, or pi. So now I have my 5 points. Another way you could think of it is, since my horizontal component's being compressed by a factor of 2, so our first main points, you would just divide each of those by 2. So 0 divided by 2 is 0, pi over 2 divided by 2 would be pi over 4, and then pi over 2, and then 3 pi over 2 divided by 2 would be 3 pi over 4, and so on. Okay, so we're just compressing each of those horizontal components by a factor of 2. All right, so then we're going to draw our same basic shape. So remember that the sine graph starts at the midline. So our midline didn't change, it's still at 0. And so this time, instead of going up, we're going to be going down because we have a negative in front, which is going to reflect this across the x-axis. So we're going to go to our next point down. So at -1 is at pi over 4. Then we're going to come back to the midline. We're going to go up to 1 and then back to the midline at pi. And so then we can graph our sinusoidal shape. So in our final part of example 1, when we're just looking at sine, we now have both a horizontal and a vertical stretch or compression. And so notice in example 1, we're not looking at the vertical and horizontal shifts, just the compressions and stretches. Okay, so the amplitude again is just whatever the coefficient of the sine graph is. So we have an amplitude of 4, and then the period is affected by that 1/5. So remember, to find the period, we have the period of sine is 2 pi, and then we're dividing by that 1/5. In other words, if you're dividing by 1/5, right, you're really multiplying by a factor of 5. So if I have a factor of 1/5, then remember, you're actually going to be multiplying by 5. So we're going to actually get a bigger period than the 2 pi. So we're going to have a period of 10 pi. So that means that we're going to have that one whole cycle stretch a span of 10 pi. So it gets really, really, really stretched out. All right, so let's go ahead and draw our axes. So the way I do this is I just go ahead and set my amplitude. I just draw a tick mark on my y-axis at 4 and -4, and so that's kind of like the range of where my graph is going to go. And then my period is 10 pi. Again, I didn't have any horizontal shifts, so we're starting at 0 and we're going to end at 10 pi. So I put my very ending tick mark at 10, and then I go halfway, halfway. So halfway would be at 5 pi. Halfway again would be 5 pi over 2. So I have my starting point at 0, and then between each tick mark is 5 pi over 2. So this is 5 pi over 2. If I add another 5 pi over 2, that would be 10 pi over 2, right, or 5 pi. So 10 pi over 2 plus another 5 pi over 2 would be 15 pi over 2. So I'm just showing you different ways to make sure that you get these tick marks correct when we're adding fractions. So another way you could do it is take these two, 5 pi and 10 pi, add them together and divide by 2, because you're just finding the average. So 5 pi plus 10 pi is 15 pi divided by 2. So now you have your evenly spaced 5 points. So now we're going to graph sine. So the hardest part is just making sure that your tick marks are labeled correctly on the x and y axes. Then you just draw the same basic shape that you've been drawing. So sine, again, starts at the midline, which is still at 0. And since this time we have positive, it's going to go up to its amplitude of 4, back to the midline, down, back to the midline. And there we have our transformed graph. So all of these graphs, they're going to look the same, right? Because we're looking at the same basic shape of sine and cosine. It's just looking at the tick marks that help us kind of see how they were transformed. So that was our basic graphs, horizontal and vertical compressions and stretches of sine. In the next video, we're going to do the same thing with cosine.